Hello dear colleagues, partners and investors. You're in the channel Duyunov's Motors and I'm Alexander Sudrev. Today we have a very interesting topic. We will talk about induction electric motors. For your information, the company Sovelmash develops and designs ultimately new, promising induction electric motors based on the combined winding technology Slavyanka. It means that the motors are enhanced with the unique performance features, such as an increased life, increased power and increased energy efficiency. Meanwhile, much less electric steel and copper is required to produce one motor of this type than for standard motors. For instance, it's possible to make 4 induction electric motors based on the Slavyanka technology out of 3 standard induction electric motors. And now let's move from words to action. Now, we are in the winding workshop of Sovelmash. At the background you can see the winder's workbench. This is a place where the motor winding process takes place, and of course the constituent parts of any induction electric motor. Let's make it clear what we need it for now and why are we here. To begin with, we need to understand what makes any motor. Of course it's a frame. In this case, the frame is empty. As you can see, this is a frame of a standard classic motor. Then, we can see the stator packs, both of a standard one and produced by our company. The tooling, used for winding the coils, which in their turn will then make the winding. And now let's elaborate on the tooling in more detail. In order to wind any coil, it's necessary to make the tooling itself. In our case, we produce it using the additive technologies, a 3D printer in particular. After having prepared the required amount, we mount the tooling on the special guide and then place it in the winding unit to perform the winding process. You can see the result here. Also pay attention to the special technological pins that allow to keep our coil in a neat and careful way. Now let's move to the metal part of our motors. This is a stator pack and the rotor pack. If we have a look at the standard stator pack, we can notice a lot of interesting details. First, we can see a large number of technological grooves that compromise integrity of the pack, and we also can see that the packs have been assembled by means of bracketing. In other words, it means that the packs are a bit indented and deformed, and this takes its toll on the future motor operational capability and affects its performance. Before moving to the stator pack produced by us on the territory of Sovelmash, with the help of our laser equipment, let's get it figured out what makes the performance features of any induction electric motor. Of course, the first thing taken into consideration is the calculation. It's calculating the required power we need in this particular case. In other words, every motor is calculated for a particular task. It's normal, it's always been, and it will be performed in the future. The next thing is the technology used for assembling a motor. For instance, it's either the star or delta winding type that is currently used worldwide. In our case, it's a combined winding Slavyanka. Slavyanka enhances the motor performance and makes it more effective. As an example, I can say that thanks to the using the Slavyanka technology, we can get an IE3 class motor in the frame of an IE1 motor with the same basic mounting dimensions. This is breaking news, but what else impacts the performance of the future motor? Of course, the technology used for producing the constituent parts and elements. We have already mentioned that we have our original tooling, our original coils that are wound directly on the territory of Sovelmash, and now we move to the most interesting part, metal part, the stator. You have already seen the stator pack of a standard motor, and now pay attention to the stator pack that has been produced using the laser equipment on the territory of Sovelmash. The pack is more even, it's not deformed. There are no indentations. The welding line looks very neat, and As a matter of fact, all of these make one complete integral unit on the surface. It means we will not get any unexpected or adverse changes of electromagnetic field that appears as a result of any induction electric motor operation. The same applies to the rotor package that we now don't have here. We should emphasize that we live in 21st century. The technologies that are currently being used to make an induction electric motors worldwide are imperfect. A lot of producers use outdated technologies. They use outdated plant capacities. There are no technologies that could considerably improve the quality of the assembly, the quality of the parts themselves, and we are using only modern assembly methods, modern calculation methods, and everything we're doing contributes to achieving the results we are showing to you. We are regularly showing them to you in our videos. Thus, answering the question why the project needs the innovative center if you can do things in a garage, using the current production facilities, or modernize the existing plant. The answer is simple. It's impossible to modernize the existing production facilities, and the capacities the garage can handle won't be enough. In order to achieve the results we have now achieved by making the stator pack, we had to use the laser equipment. It's quite large, complicated, and expensive, and the innovative center will have a large amount of specialized equipment. The production lines will be adjusted for producing pilot batches that in future will demonstrate the efficiency of our technology, and a particular motor model ordered by our future customers. I suppose the question is settled here. We are done for now. Make sure you subscribe to the channel, click the like button and the bell icon, and don't forget to register in the back office of the project Duyunov's Motors. See you again.